So dear students, in this lecture we are going to study about the comparators. So we can define comparators that a device that compares two quantities is called comparator. These comparators are classified as a amplitude comparator or phase comparator. So what we see here, that a comparator, that is a device that compares two quantities. We must have two quantities to compare, then only we can compare something. Otherwise how can we compare? We must have two quantities. So based on these two quantities we can compare that someone is greater than other one or someone is less than other one. So these comparators are nothing but they are classified in two types: amplitude comparator and phase comparator. So what is amplitude comparator? The amplitude comparator means if we have two quantities, then we want to compare something between the both quantities. So the amplitude of one quantity will be greater than the other. It means that we want to compare two quantities in terms of the amplitude. That's why it is called the amplitude comparator. Now how here we are going to define that? Let us assume that S0 is the operating quantity and SR is the restraining quantity. What is operating quantity? Operating quantity means the quantity which operates something. And what is a restraining quantity? A restraining quantity means the quantity which restrain or object something or to stop something. For that we call the restraining quantity. So the amplitude comparators follows the law. What is the law? If S0 is greater than SR, then it gives the trip command, else restrain. So here we have two quantities, S0 and SR, and we want to compare between these two quantities, that is between S0 and SR. So if S0 is greater than SR, then it will give a trip command to any device. It may be a relay, it may be a circuit breaker, it may be an isolator, it may be any protecting device. So here let us say this is a device where we have two inputs, that is S0 and SR, and this is a device which we want to compare these two input quantities. So depending upon this law at which this amplitude comparator works, that is S0 is greater than SR. So if S0 is greater than SR, then it will give a trip command. This is the trip command. Let us say this a circle is shown here and a radius is shown with the vector SR and another vector which has been shown by S0. So what we can see, S0 is greater than SR. Just see, the amplitude of S0 is greater than SR. So what will happen? Until this SR exists, it means a radius inside the circle, complete radius, S0 will not be greater than SR. It means inside the area of circle, this relay will be restrained, or the output of the comparator will be in restrained condition. And outside this circle, when S0 will become greater than SR, then it will give the trip command, because in that situation S0 will be greater than SR, because we are comparing here amplitude. So amplitude of S0 will be greater than SR. So it will give a trip command outside the circuit, because we know that this amplitude comparator follows the law of amplitude. It compares between two amplitudes. Similar example has been shown here that it responds only to amplitude. How? Let us say this is the coordinate axis, this is the SR quantity, that is called the restraining quantity, and this is the S0 quantity, that is called the operating quantity. So what see in this case, S0 magnitude of or amplitude of S0 is greater than SR. So in this condition it will have a trip command. It means relay output will be in trip command. Similarly, in this position, if this S0 vector moves to in this coordinate, so here also we see that this S0 magnitude or amplitude is greater than SR. So here also the amplitude will compare and it will give the trip command. Similarly, if this operating vector moves in this coordinate, here also it compares that this S0 is greater than SR. So here also it will give the trip command. Similarly, see this example, if again S0 has moved to in this quadrant, that is in the first quadrant. So what we see here, again S0, amplitude of S0 is greater than SR. So again we see that in this case the comparator will issue the trip command. So in all four cases, first, second, third, fourth, we had a trip command. Now let us see the restraining part. The restraining part has been shown here, that let us say this is the S0 operating quantity, this is the amplitude of operating quantity, and this is the SR restraining quantity amplitude. So what we see here, that the operating quantity magnitude, this one is less than this restraining quantity magnitude. This is the SR. So S0 is lesser than SR, or we can say that SR is greater than S0. So if this situation exists, then amplitude comparator will be in restrained position. It means it will not give any trip signal. It will try to hold the system in same position, or it will restrain the system. Similarly here, once we say, if this is the operating quantity and this is the restraining quantity, so what we see here, that again this S0 amplitude is less than the restraining signal, SR restraining signal. So in this case also the comparator will compare both the magnitude and it will issue a restraining signal, restrain command, because here S0 is less than SR, SR is greater than S0. So we have seen here in case of amplitude comparator various cases, that how the amplitude comparator will work. These comparators are required in the production devices to issue a trip command or restraining command as per the quantities of inputs available as input to the comparator device. So this overall we have understood about the amplitude comparator. Now let us see if condition comes as a threshold condition. That is, threshold condition means if SR and S0 both are equal. Here also if SR and S0 both are equal. Here also if SR and S0 both are equal in this condition also. So if both inputs are equal in magnitude, that is S0 are equal to SR. In all the cases I have shown here, both inputs are equal. This situation is called the threshold condition, and if this condition is there, then the signal will remain there itself, because it is a threshold condition which is waiting to operate some signal. So if both quantities are equal, we call it is a threshold condition. So far we have discussed the amplitude comparator. Now let us discuss the phase comparator. What is phase comparator? So in amplitude comparator, we have discussed that if there are two input quantities, so we can compare the amplitude of the two input quantities and accordingly we give the output, either a trip command or a restraint command. But here in phase comparator, we will not compare the amplitude, we will compare the phase of the inputs. So let us say first I discuss the cosine type of phase comparator. So what is this cosine type of phase comparator? It has a two phasor, let us say SP and SM. What is SP? SP is the polarizing or reference input, and what is SM? SM is the measured input. These are the two input quantities which can be denoted for the phase comparator, or that is called the cosine type phase comparator. So what law follows? What the fundamental law follows this phase comparator? That if argument between SM and SP is in between minus 90 degree and plus 90 degree. So what it exactly explains that if the argument, that is the input phases of SM and SP lies between 90 degree and plus 90 degree, then it will issue a trip command, otherwise it will have a restraint command. So again we have this is a comparator, this has a two inputs SP and SM, and will have a output as a trip command. So let us see in this diagram here as shown. We have angle minus 90 and plus 90, and we have a input quantity SP and SM. Here both SP and SM, they are equal in amplitude, but this is a phase comparator, so we are not bothered about amplitude of the SP and SM. We are bothered about the phase angle of, or phase angle between SP and SM. So what we see here, SM is drawing in this first quadrant, but it is inside the plus 90 degree angle and minus 90 degree angle if we take a reference from the SP. So in this condition it will issue a trip command, otherwise it will have a restraining command. Let us say in this case, if SM and SP both are just at same place, SP is greater than SM has shown, but that does not have any meaning because we are studying here a phase comparator. But it is lying between minus 90 degree to plus 90 degree angle, so it will issue a trip command. Similarly, see here, in this case also it is same situation as I have discussed here, but here let us see, this SM is changed to this position, SM is changed to this position, and SP is here. But again both the vector are lying inside the minus 90 to plus 90 degree position. This is the position, this is the position. So again in this condition the comparator will issue a trip command. Now the situation is changed. Just see here, in this diagram, this is the SP and this is the SM. So SM has crossed the minus 90 degree and plus 90 degree border. So in this case, the face of SM is crossed the boundary of plus 90 to minus 90 degree. So in this situation, the comparator will issue a restraint command. Similar to this position here, we see that SP is lying at this original position and SM has come to this third coordinate. So this SM has starts the plus 90 degree and minus 90 degree border, it means the law which follows here. What we law? Law says that the argument of SMSP, it means the phase between SMSP, if lies between the minus 90 degree and plus 90 degree angle, then it will issue a trip command, otherwise it will have a restraint command. So here phase angle is crossed this boundary, that's why, because SP is here and SM is here. So in this condition it will issue a restraint command. And already I have told you what is the trip command, what is the restraint command. Trip command is to issue a signal for a device to trip, and restraint command is to issue a signal to stop the device or restrain the device. So this is called the phase comparator. So I think you might have understood about the amplitude comparator and phase comparator and how they works. Now let us see, threshold condition will lie in this case also, that is, if SP and SR are at 90 degree position, or SP and SR are SM is here. Just see, SP and SR and SP and SM, we can say SM or SR. So if both the vectors are placed between the 90 degree position, that is plus 90 or minus 90, so similar to place of amplitude comparator, here also this situation will be called a threshold condition, because beyond that there will be a restraining signal, that's why it will be called the threshold condition. So in first type of phase comparator, we are discussing about the cosine of phase comparator. Now we will discuss about the sine type of phase comparator. So what is sine type of phase comparator? Again, in this type of comparator, it has two inputs, that is SM and SP, which already I have discussed. And this comparator follows the law that if argument of SM and SP, that is lie between 0 degree angle and 180 degree angle, then it will have a trip command, otherwise it will have a restrain command. Let us say, for example, that this is 0 degree and this is vector, and 180 degree position is this one. So if this vector is rotated from 0 degree and reach to here, still it lies above the 0 and 180 degree position. So argument says that if this vector position is within the 0 and 180 degree position from this reference, so it will issue a trip command. So that's why here it has been shown a trip command. Simply just see here, this is the SP vector, this is the SM vector. So SM vector is lying from the SP between the 0 to 180 degree position. So again in this situation it will issue a trip command. Similarly here also just see the SM and SP. So what we have, this SM-SP lies here in same position, it will issue a trip command. But just see here, in this case SP is here, but SM has crossed the 180 degree boundary. It has exceeded a 180 degree angle SM from SP. So in this condition it will issue a restrain command. Here also just see SM has further changed position, so it has again in exceeded condition from 0 to 180 degree. So argument says that if the angle between the two quantities has changed above the 0 and 180 degree position, then it will issue a restrain command. So what we see that in both conditions, this one we have a restrain command, and in this position we have a trip command. Here this may be overlapping situation, both SM and SP and SM both are just overlapping among each other. So this will be the threshold condition. This will call the threshold condition. So what we have learned here, that in amplitude comparator we compare the two amplitudes and issue a trip command or string command. However, in this phase comparator we have studied the cosine type of phase comparator, and this is the sine type of phase comparator, where the arguments are different in both the cases, and based on the argument the phase comparator operates. Now let us say we will study about the amplitude comparator. So amplitude comparators are classified as integrating type comparator, instantaneous comparator, and sampling comparator. The integrating time comparator has been shown here with the help of this diagram. What is here shown, that we have a two bridge rectifier. This is one full bridge rectifier and this is also full bridge rectifier. This is a transformer. Secondary of transformer is connected to this bridge rectifier and here also to this bridge rectifier. We have two operating quantities, that is I naught operating quantity and IR, that is the restraining quantity. This I naught is proportional to the load current and this IR, that is the restraining quantity, which is proportional to the voltage. So once these two quantities are applied here, so how the circuit works, let us see. I naught is flowing from here. This I naught are coming to the polarized relay. This is the polarized relay and comes back to the negative. Now IR, restraining quantity, operates in this way. From this positive, IR is coming through the polarized relay and comes back to this circuit and goes back to the negative. So what we see here in this diagram, that I naught, that is the operating quantity which is coming from top to bottom. However, the restraining quantity, that is IR, is flowing from bottom to top like this. So based on these magnitudes of the I naught and IR, that is, if the difference between I naught and IR is positive, it means I naught is greater than IR, then this polarized relay will operate, otherwise it will be restrained. These characteristics are shown here, that this is the relay voltage, this is the plus voltage, this is the minus voltage. So what we see here, in this condition, if I naught is greater than IR, then this will have a trip command, otherwise it will have a restraint command. So output of the bridge rectifier is coming here as input, and this is called the averaging circuit. So depending upon the positive output of this bridge rectifier, the averaging circuit will issue a output or the command, whether it is a trip command or whether it is a restraining command, and it will be given further to the production device. So this is how this integrator comparator operates. Here it is written as I naught is proportional to the load current and IR will be proportional to the system voltage. So there will be a two parameters, that is the load current and the system voltage. So based upon these two parameters, this integrating comparator works. Now next comparator will be discussed in next class. This is the end of the lecture. Thank you very much.